Hi, in this video, we're going to do an overview of single area OSPF v2. Open shortest path first is the name of it. Okay, so looking at our routing protocols, we have distance vector routing protocols, RIP and EIGRP. Really no reason to be using RIP anymore. We have link state, OSPF, and ISIS. And in our exterior gateway protocol, we have BGP, Border Gateway Protocol. So we're going to be looking at OSPF v2 and in later videos v3. There is OSPF v3, which is for IPv6. There's also OSPF v3 with address families, which supports both IPv4 and IPv6. Okay, so OSPF is a classless routing protocol, not classful like the old RIP was, RIP version 1, and really not too much reason to be mentioning that anymore. But, excuse me, it is a link state routing protocol, so see my video on link state operations for more information on that. Uses areas for scalability, so we'll be doing a video on multi-area OSPF. And the current RFC for OSPF v2 anyway is RFC 2328, which defines the OSPF metric as an arbitrary value called cost. Cisco IOS uses cumulative bandwidth, so the bandwidth of all the outgoing or egress interfaces to the destination network, and it's a very simple, straightforward way of calculating the OSPF cost metric. Okay, initially developed in 1987, IETF working group. OSPF 1 was published in RFC 1131, and OSPF v2 in 1991. And John Moy has done the prominent work on that routing protocol, OSPF. At the same time, ISO was working on ISIS, intermediate system to intermediate system. But IETF chose OSPF and recommended that as the interior gateway routing protocol of choice. In 1998, OSPF v2 spec was updated, RFC 2328, and is the current RFC for OSPF v2. ISIS is also a very popular routing protocol, and some argue better designed with things like fixed length TLVs, type length values, but that's for another video, and some other design features that some argue is better. By the way, OSPF, there's a book there by John Moy, who again was really the prominent developer of OSPF. There's an interesting chapter in that book that talks about the development of this routing protocol. Sometimes we tend to think that, there's like a scientific method or something. There's only one way to do things, and it's pretty much, cut in stone how we do this and no other ways. But as you'll see, reading, things like this book here, at least that particular chapter, and looking at other books too that talk about these things, the development of routing of protocols in general, that there's great room for debate, and people to this day debate, what is the best protocols and how these protocols should operate and what their features should be, and functions and algorithms and all sorts of things. Jeff Doyle wrote a book on OSPF and ISIS. Jeff Doyle, kind of my generation, he's a hero. Many of us kind of cut our teeth on routing protocols, reading his Routing TCP/IP book. It was by Cisco Press, Volume 1 and Volume 2. And he's still out there today, well-known network engineer, writer, author, in a lot of the conversations with IETF, and very, very knowledgeable person. All right, let's get into OSPF here. So we have both OSPF v2, which has an OSPF v2 adjacency database and link state database, which then populates the IPv4 routing table. For OSPF v3 over IPv6, we have an adjacency database and a link state database, which then populates the IPv6 routing table. Now, OSPF v3 with address family actually supports both of these and combines the adjacency and link state databases. And that's for another video. Okay, as far as OSPF message encapsulation. So we have different OSPF packet types which share a common header, OSPF packet header. We'll be looking at some of those packet types shortly in another video. They're encapsulated in an IP packet using either one of two multicast addresses for IPv4, IPv6, and we'll be talking about those a little later. And that's all encapsulated in Ethernet frame when sent over Ethernet, of course, as a destination MAC address of IPv4 or IPv6 multicast address. Okay, the OSPF algorithm, and again, looking at the video on link state operations goes over this, but we build our link state database from sharing link state advertisements flooded within the routing domain or within a specific area. Run the SPF algorithm. From that, we come up with a SPF tree, and those best paths are offered to the routing table. As far as OSPF goes in administrative distance, it has a default administrative distance of 110, which probably doesn't mean a whole lot to you right now. Again, administrative distance is about if a router, if the iOS learns about a specific route, a route to a specific network from more than one source, which one should it populate the routing table with? Which one is it? Does it consider most trustworthy? Lower the administrative distance, the better. So you see connected networks can only be 0 and nobody can have a administrative distance of 0 other than a directly connected network. Static routes default to a 1, and then we have different routing protocols with different administrative distances. And this is not by any means saying which is a better routing protocol. A lot of this has to do with how we redistribute between routing protocols, which is for another video. Okay, so OSPF is based on Dijkstra's algorithm, which I don't go over here, but I did do a video on Dijkstra's algorithm. So if you're interested in that, go to my playlist and look for Dijkstra's algorithm, and I actually explain how Dijkstra's algorithm works. All right, so this is just an overview of single area OSPF v2. Many more videos to follow.